Introduction to matrices. An element is identified by the row and column it belongs to. So this is A11. Second column will be row 1, column 2, row 1, column 3. If we have row 2, column 1, row 2, column 2, row 2, column 3. The size of a matrix is known by N and M, this is the number of columns, this is the number of rows. So, for example, in this matrix, it is a 3 by 3 matrix. A vector can be a row vector because it has a single row and multiple columns, or it can be a column vector because it has multiple rows but a single column. A transpose of a matrix for instance, if this is A, the transpose of matrix A will be the row now becomes the column. That's the meaning of transpose. A zero matrix is when you have all the elements in the matrix, regardless of the size, all the elements are 0. A diagonal matrix is when the diagonal elements here, for instance 2, 4 and 3, are not 0, but the rest of the matrix are 0. And the most commonly used matrix will be the identity matrix, which represents 1. Regardless of the size, again, it is a diagonal matrix where all the other elements are 0. A triangular matrix is when the elements on the upper triangular, for instance here, are all non-zero and the remaining are 0. So we call this a triangular matrix, and this is an upper triangular. So you can imagine what would be the lower triangular. Now let's move on to operations. First operation will be addition. Let me give you say two matrices where A is a scalar multiplication, for instance 3 times A now a multiplication, for instance you want to multiply A times B. Okay, rule is that the dimension of A and B must be such that this is the dimension of A and this is the dimension of B. Now the rule says that M of A must be equals to N of B. So you must make sure that these two are equals to each other, and the new matrix, let's say we call it C, will have the dimension of NA times MB. For instance, if you have a matrix which is 4 by 3 and the other matrix is 3 by 2, so they meet the rules, they meet the conditions, and the new matrix will be a 4 by 2. In another example, if 3 by 1 and 3 by 2, so they did not meet the condition, cannot be multiplied. Is that clear? So how can we multiply A and B? We multiply by row and column. So row A will be multiplied with column B. So in one position, so 3 times 5 is 15 plus 2 times 0. 3 times 5 is 15, 2 times 0, 0. Then one more will be 3 times 1 is 3 plus 2 times 5 which is 10. In the 2 1 position will be row 2, 6 times 5 because we're looking at row 2 multiplied with column 1. So 30 plus 0 times 0. The last column and row will be this one. So 6 times 1 is 1 and 0 times 5 is 0. So the answer is 15, 13, 30 and 6. That's all for now.